Hi everyone, welcome to another maths video by Maths with Sarah. So today we're going to be taking a look at this question where we've been given the equation of a curve and we've been given the equation of a line. And we've been asked to show that the curve and the line have exactly one point of intersection. So if you're imagining this on a graph, so it says don't use a graphical method, but let's just have a think about how this all works. We've got a graph looking like this. We've got a curve, so we know it's got an x squared, so it's going to look something like this, and then we've got a line. So typically, if a line crosses, if a line crosses a curve, it has 2 points of intersection because it will cross at 2 different points. But here we've been asked to show that the line only has 1 point of intersection. So, for example, going something like this, where it's only going to intersect the curve at 1 point. But we've been asked to show all this without using a graph. So before I tell you what we're going to do, I encourage you to pause the video around about now, have a think about how you would solve it. Even if you struggle to do the full question, just have a think about what method you would use, and then pop back and I'll go through it with you completely. Okay, let's get going. So we have got a curve and we've got a line. Now, hopefully you remember that if we're trying to find a point of intersection between 2 lines, we can use simultaneous equations to find the point where x and y are equal in both of those equations. And the exact same principle applies here. So we can set these two equations equal to each other because they both equal y. So we can set these two equal to each other. So we'll have x plus 2 equals 4x squared plus 5x plus 3. And we can solve them exactly the same as we would solve simultaneous equations if we only had one, if we didn't have a curve. If we didn't have any quadratic, that's what makes this question so difficult. Is if we just had 2 lines, this would be a much easier question because it would just be a simple set of simultaneous equations. The problem with this one, as I said, is it's got a curve and the lines, we've got quadratics. As soon as you throw quadratics into the mix, it automatically makes it more difficult. Okay, so let's have a look at this then. So what we want to do is set this quadratic part equal to 0. So to do that, we'll subtract x from both sides. So that will give us 4x over here. And we'll also subtract 2 from both sides. So that will give us 1 over here. And obviously the 4x squared isn't going to change. So we'll do 4x squared here. Okay, and that is all equal to 0. So now we can solve this exactly the same as a standard quadratic. And we will pop this into brackets. So let's have a think about how we would do brackets. So we could either have 4x in one or x in the other. Alternatively, we could have 2x in each one, which I think is probably going to be what's going to work here. So let's try 2x and 2x. Yep, and then that's going to, if we put a 1 on each side, that's going to multiply to give us 1, and these two are going to times to give us 4x. So I'm always in favour of double checking that this does multiply out to what you think it's going to. It's a really easy way to check that what you've done so far does actually make sense, and also check that you haven't made a silly mistake when you've been factorising these equations. So let's do 2x times 2x, we've got 4x squared, 2x plus 2x equals 4x, and then 1 times 1, which equals 1. So excellent. We know that this part here is equal to this, so we've done our factorising correctly. So now what you can see here is that both of these brackets are identical. So rather than as normal, we would have 2 points of intersection because we'd have 2 different values of x. Instead, here we're only going to have 1 value of x because we've essentially only got one value that x can be. So this is the same as 2x plus 1 squared. And if we wanted to solve this for x, we could do 2x. Remember, we always set them equal to 0 because if one bracket equals 0 or the other bracket equals 0, you're multiplying by 0. So that means that either one of these brackets must equal 0. So now let's solve this. So we're going to end up with minus 1 over 2, and that is our only root of x. So it doesn't actually matter what else is going on. We've only got one value for x. we've only got one root, and that means we've only got one point of intersection. So if you did this typically in a different way, you might end up with two different brackets, and that's why you've got two different points of intersection. You remember how I showed you on the graph. Okay, so hopefully that made some sense. So potentially what we've got going on here is, rather than the curve like this, potentially the line is just touching the outside, or not touching in that case, touching the side of the curve, rather than actually specifically crossing it. And we might have an example like that. Okay, so hopefully that helped. Hopefully that made some sense. So we've got quadratic simultaneous equations going on here, which just sounds complicated, regardless of whether or not how difficult the actual question is. So I have got a couple of other questions on simultaneous equations and some others on algebraic points of intersection and that kind of thing. So I do encourage you to check out those other videos. I've tagged them or linked them in this video, so you can see those quite easily. And I really encourage you to subscribe, because I've got loads of other videos coming out that all should hopefully challenge you and give you something to think about. Okay, thank you very much for watching.